Hello, good evening. Yes, good evening. And we thought we'll discuss this SPD block elements, this tutorial, starting from question number mm, 56, I think. I think we discussed question number 55, 56, starting from there. Fine. So question number 56 in SPD, yeah? SPD block elements. Category. A, B, C, D are chlorides of P block elements. So these are chlorides, remember. They are chlorides of P block elements. These elements have atomic numbers less than 20. So if you look at the periodic table, hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, chlorine, neon. And then sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon, potassium. Less than 20, so calcium can't be there. So these are the elements. You know these ones won't form chlorides. No? Chlorides, chlorine also doesn't form chlorides. So these are the compounds. A description of the products P1 to P9 formed when A is reacted with a limited amount of water. B, C, D are reacted with excess amount of water given below. A is given by limited amount of water. A, limited amount. So A is limited. And B, C, D are like, large quantities, excess. Right? A, a compound with a covalent network structure. Covalent network structure is formed. Strong monobasic acid. So if it is a chloride, definitely strong monobasic acid is strong monobasic acid is what? Monobasic acid is HCl. Acid is HCl. Right? So definitely HCl. A compound with a covalent network structure. Right, okay. So maybe silicon, we'll see, right? B, a gas that turns red litmus blue. That is definitely ammonia. Ammonia and compound with a bleaching property, chloride. Okay. So nitrogen should be there. So other one is HOCl. So it is, this one should be NCl3. NCl3 gives you ammonia and HOCl. C, a tribasic acid and a strong monobasic acid. So HCl is the strong monobasic acid. Tribasic acid is, yeah, phosphorus containing material, H3PO4. That's the only tribasic acid we know, right? D, a gas that turns acidic potassium permanganate solution colorless, a colloidal solid, a strong monobasic acid. That means HCl. When you have chlorides, usually you get HOCl or HCl, right? The colloidal solid is sulfur, right? Yeah. So these are the compounds that you have. The A, B, and then C and D. B is definitely NCl3, right? C is H3PO4 and HCl. That is like, oxidation number is +5. That means this is PCl5. Sulfur to form, this should be a chloride, SCl2, right? Now, magnesium, so lithium chloride doesn't undergo hydrolysis. Beryllium chloride, boron chloride, CCl4 doesn't undergo hydrolysis. Magnesium chloride doesn't undergo hydrolysis. AlCl3 gives you aluminum hydroxide. Silicon gives you SiO2. So this one should be SiCl4, I think. But I wonder why that is saying limited. A limited amount of water, and BCD react with the excess amount of water. Limited amount of water, silicon dioxide can form into H2SiO3. I think these are the ones. A, B, C, D. What are your thoughts about that? Now you all have studied well. Answers. Everybody okay with that? But if it is wrong, tell me. Give balanced chemical equation for the reactions of A, B, C, D with water to give products P1 to P9. So A, SiCl4, when you add water, silicon takes the oxygen, chlorine takes the hydrogen. Right? If I take silicon and chlorine, this is delta minus and this is delta plus. So in water, this is delta minus and this is delta plus. So these are connected together and these are connected together. That's how you get that. So that gives you silicon dioxide. That is the network structure, and then HCl. For that you need 2 water molecules. 2 times 2, 4 HCl. So this is your P1. This is your P2. P2 is that. Next one is NCl3. NCl3 plus H2O. What would you get? You get NH3 and HOCl. 3Cl, 3 hydrogens, 3 hydrogen, 3 hydrogen, altogether 6 hydrogens, that is also 3. So P3 is this one, P4 is this one. The compound with bleaching properties, HOCl. Right? C. What is that? C is PCl5. PCl5 plus H2O gives you H3PO4. Same oxidation state. Plus the other material is HCl. 5 chlorine, 5 chlorine. 5 plus 3 is 8. That is 4. So P5 is H3PO4. P6 is strong monobasic acid. All right. D, I told you SCl2. Colloidal form is formed from chloride. This is the only one. And here it undergoes disproportionation. It undergoes oxidation, sulfur, and the other one is HCl, I believe. So sulfur, here it goes to sulfur. This is plus 2, plus 2 goes to plus 4, 2 electrons. In this side, it goes to sulfur. That is also 2 electrons. So this is 2. 2 times 2, 4. 4. 4 hydrogen means you need to have 2 water. That is your reaction. The oxidation and reduction take place. Now P6. So P7 is the gas. P8 is the colloidal material. P9 is the strong monobasic acid. So these are the ones that you get. Right? They are the chemical reactions. Then they ask, write the balanced chemical equation for the following reactions. P1 with sodium hydroxide. What is P1? P1 with sodium hydroxide. SiO2. P1, SiO2. SiO2 with sodium hydroxide, what do you get? With Na2SiO3 plus water. So two hydrogens here. 2, 2, 4, 3 plus 1 is 4, 2 hydrogens, 2 sodium. Sodium silicate, Na2SiO3. P3 with magnesium, ammonia and magnesium. NH3 and magnesium, that's a very special reaction. Just like sodium reacts, but it gives you the nitride, Mg3N2, and hydrogen is evolved. 3 magnesium, this is 2, 2 times 3 is 6, that is 3. Magnesium nitride. P7 with acidic potassium dichromate. P7 is sulfur dioxide. Sulfur dioxide plus dichromate. What will happen? Sulfur dioxide turns into sulfate. Dichromate turns into Cr plus 3. Okay, plus 6 to plus 3, 3 electrons, altogether 6 electrons. Here, plus 4 to plus 6, that is 2 electrons. Multiply this by 3. This is 2 chromium, 2 chromium. So need to add how many H pluses? So 1 H plus, I think 2 H plus. No. Yeah, 2 H plus. 2 H plus means 1 water molecules. Let us double check. 3 times 2, 6, 6, 6, 12 plus 1, 13. 3 times 12, 12 plus 1 is 13. So that is your reaction. What do you think about those answers? Did you all get these answers? Hmm? Yeah? Right. Okay. So you agree with that, right? Good. Right. Good. Very good. Very good. Right. So now let us go to the next topic. Next question. Next question is part B. Here, right? A student provided bottles PQRST UV, UU containing aqueous solutions of aluminium sulfate, Al2SO4 thrice, aluminium sulfate, sulfuric, sodium thiosulfate, barium chloride, lead acetate, and potassium hydroxide. So there are 6 tubes or 6 samples, not in order. Some useful observations from their identification on mixing 2 solutions at a given time are given below. 2 solutions at a given time are given below. T and R gives you a colorless solution. So you can't really say anything about that. P and R gives you a white precipitate. Right? SiO2 is acidic oxide, right? Like just like carbon dioxide. Just like carbon dioxide dissolves in sodium hydroxide, silicon dioxide also dissolves in sodium hydroxide. Right? Right. So what you get is some useful observations, right? T and S gives you a gelatinous white precipitate. Let us see whether there is a gelatinous white precipitate. May then a gelatinous white vein. Aluminium and then this KOH. So T and S, gelatinous white precipitate. So this can be TOS. This can be SOT. Right? So U and R gives you a white precipitate. There are a lot of white precipitate. P and Q, white precipitate turns black on heating. White precipitate turns black on heating. That is definitely thiosulfate is there. So this is P and so this is POQ. This is QOP. Right? P plus U, a white precipitate that dissolves on heating. dissolves on heating, that is definitely there's a chloride, this should be present, barium chloride. Lead chloride is the one that will dissolve when you heat. So P and U. So this can be P or U, right? So, like, now the common one to this one is, right, P should be this one, because this is, right, if you look at this one, P cannot be sodium thiosulfate. If P is giving a precipitate that dissolves, so P should be this. So I will erase this one. This is definitely P. This is definitely U. If this is P, this cannot be P. This should be Q. Right. Right. Uh, okay. Right. So that is okay. Now, T and R gives you a clear solution. T and R. So that means this might be that. Neither. This is T nang. This might be R. I'm just guessing. Huh? I don't know. We'll see. Right? It gives you a clear solution. Clear solution. So what is that? Yes, T. T and R gives you a clear solution. P and R gives you a white precipitate. Hurry. Lead sulfate is a white precipitate. And T and S gives you a gelatinous white precipitate. This is definitely, this is then, that is S. S. Gelatinous white precipitate. U and R gives you a white precipitate. And P and Q gives you a white precipitate that turns black on heating. Hurry. P and U gives you a white precipitate dissolves in heating. So what is the only thing that is remaining? P, Q, R, S, T, U. You have B also. P, Q, R. P, Q, R, S, T, and U. Right. Okay. So everything is understood now, I think. Right? Right? Clear? Right? P, Q, R, S, T, U. So identify P to U. Right? Give balance chemical equation for the reactions 1 and 1 to 5, 6, 1 to 6. 1. T and R. What is T? KOH. KOH, T and R, sulfuric. H2SO4. It gives you K2SO4. K2SO4 plus water. So this is 2. This is also 2. Right? Clear, colorless solution. K2SO4 dissolves completely. P and R gives you a white precipitate. P and R. Lead acetate. Pb acetate means CH3 COO minus. Right, twice. Lead acetate plus P and R. R is sulfuric. You get lead sulfate. Lead sulfate is a precipitate. PbSO4. Lead sulfate and acetic acid. TNS gives you a gelatinous white precipitate. TNS, potassium hydroxide and aluminium sulfate. Al2SO4 thrice. What would you get? You get aluminium hydroxide. That is the gelatinous white precipitate. And then other one is K2SO4. Right. Aluminium hydroxide. So 2 aluminium hydroxide, 2 times 3, 6 potassium. This is 3 potassium. U and R. U and R. Barium chloride, sulfuric. H2SO4. You get barium sulfate plus 2HCl. Barium sulfate is a precipitate, white precipitate. P and Q, formation of the white precipitate. Lead acetate, this is sodium thiosulfate. What do you have? Lead thiosulfate, PbS2O3. CH3COONA. This is the white precipitate that you get. So it turns black on heating. PbS2O3, when you heat it, it gives you lead sulfide, black precipitate, and sulfur dioxide. Sulfur dioxide reacts with water and gives you sulfuric acid. Black precipitate. Huh? This is the white precipitate. Right. What is the next one? Uh, Sixth one is what is that? P plus U. P plus U. Lead acetate plus barium chloride gives you lead chloride. Plus CH3COO twice barium. Barium acetate. Did you understand that? Can we interchange T and S? Very well, because it won't give you like, I don't think it will give, because when you have like aluminium sulfate and sulfuric, you don't have reactions. So you can't interchange it. There should be a reaction. This is a reaction. Right? That's it. That's what you get. Neither. What are your thoughts on that? Everybody? Can't barium chloride react with sodium thiosulf Na2S2O3? Sodium chloride and barium thiosulfate, white precipitate. But then black precipitate comes with this lead thiosulfate and water. Black color comes from lead sulfate, lead sulfide and silver sulfide. Barium sulfide is not black in color. It says when you heat it, it turns into a black precipitate. Okay. So if you are okay with this, then we'll go to the next question. Yeah. So next question, taken up this. So this is the question you have, right? Okay. Write chemical formulae of the substances A to Q given in the following flowchart. Chemical equations and reasons are not expected for the identification of substance A to Q. The symbols given in the box are used to represent solids, precipitates, solutions, and gases. So, like, now when you look at this, the square and the triangle, those ones, we are not really sure. It's very difficult to look at the boxes and, those. So make sure to use these symbols and record the physical state, first thing. So this is a solid. This is a solution, aqueous solution. This is a gas. Triangle means it's a precipitate. A solid. This is a solid. This is a solution, aqueous solution. This is a aqueous solution. This is also a aqueous solution. Aqueous, aqueous, This is aqueous. Triangle means solid, solid, solid. And then this is a gas. This one is a solid. So keeping that in mind, this is also a gas. Right. Okay. Colorless aqueous. Ne? Right. So you can see, check whether you can work it out. Metal dilute sulfuric pale green. Pale green color. Now green color comes from chromium, nickel, Fe plus 2, and then maybe vanadium plus, plus 2, right? Plus 3, vanadium plus 3, right? These are the pale green ones. So you can have Fe plus 2, nickel plus 2, chromium plus 3, or vanadium plus 3. These are the ones that you can have this. And then when you add sodium hydroxide, it's dirty green in color. Dirty green color is characteristic for what? What is the dirty green color? We always say dirty green color with respect to which one? Fe plus 2. Yes, Fe plus 2. So we have this question whether it is Fe plus 2. Right? Dirty green color. And then you add something here, colorless something, and it turns into reddish brown color. Definitely Fe plus 2 and plus 3. No? So this is definitely Fe plus 2 and plus 3, I think. Right? This is reddish brown color comes with this. Dilute nitric and then H plus. Oh, yeah. Go back to that. Right, okay. So the Fe plus 3. Dilute nitric and you add H plus 3, H here. Dark blue, I feel like that it is potassium fer, fer, ferrocyanide. නිකන් මම නිකන් ලියන්නේ K3 K4 FeCN6. Dark blue color. You'll see, I'm not sure. Right? It's a reddish brown color, and then it gives you a solid heat. Reddish brown color, it gives you a solid Fe plus 3, so it should be Fe plus 3 something. Then you have LM, strong monobasic acid. Strong monobasic acid, yellow brown color, silver nitrate, white precipitate diluted in a clear colorless solution. That means this is definitely chloride ions are there. Maybe. So you get AgCl, silver chloride. Clear colorless solution means diamine complex. Diamine complex. Huh? Dilute sodium hydroxide turns filter paper, moisten, Nestlers reagent brown. That means you have ammonia. This is ammonia. So it you add this ammonium salt. Ammonium salt. Deep red color, yellow brown deep red color means ammonium thiocyanide. So this one it gives you FeSCN minus 2 complex. බලමු අපි නිකන් පිල් figure we are gradually figuring it out. Right. ඊට පස්සේ you have the chloride. You have the chloride here, yellowish brown color, silver nitrate. You add a chloride, yellowish brown color, chloride. So that means J is black color, pale yellow, milky white color, strong monobasic acid. Colorless bad odor. Colorless bad odor means hydrogen sulfide. Right? Okay, hydrogen sulfide. Pale yellow color is sulfur. This is, what is this? Yellowish brown color, ferric sulfide. If we do is 3. Strong monobasic acid. Chloride, HCl. This might be FeS, ferrous sulfide, because it can undergo reduction. Right? Dirty green color, colorless. E is a compound that contains two elements belonging to the first two periods in the periodic table. First two. First two periodic in the periodic table. We're going to make a hydrogen peroxide in there. So that oxidizes. Now I think it is okay. Write the complete electronic configuration of A. What do they say? Write the chemical formula of the substance A to Q in the following chart given below. A to Q represents the precipitate. Sorry, right. So pale, colorless, odorless gas. Colorless, odorless, sulfuric. So this might be ferrous carbonate. So this C might be CO2. Pale green. But A is, right, just check whether this is right, ferrous carbonate. A, because it gives you carbon dioxide, a colorless, odorless carbon dioxide. Right, okay. So we'll figure it out. A. Now sulfuric and sulfuric, pale green color. So this is B. B is ferrous aqua complex. 6,2 plus. Ferrous aqua complex, B, pale green. C is carbon dioxide. C. That's okay. Right? Check. You add sodium hydroxide, Fe plus 2, dirty green precipitate. CD, it is ferrous hydroxide. Ferrous hydroxide is D. Right? If you add the hydrogen peroxide to this, it gives you oxidation, precipitate. Sodium hydroxide. So E is hydrogen peroxide, H2O2. And F is, what is F? It oxidizes. Hydroxide turns into ferric hydroxide, because how do I know it's a reddish brown precipitate? It says it's a precipitate, ferric hydroxide. F. Dilute nitric, you dissolve and you add H. And if you add H, it gives you the complex with Fe plus 3. So Fe 3. Fe4, Fe4, Fe CN6 3. Okay. So that's a blue colored precipitate that you get. Right? So H is this, H is what is added. Reddish brown color, and you heat it. That is ferric hydroxide is equal to G is Fe2O3. So oxide G. Where's H? H is H. This is actually I. This is I. The precipitate is I. Right? The material that you add is, what is that? K4 FeCN6. Tell me if I am wrong, right? Okay, H. I. See, then they say J. J is yellowish brown. There's a chloride. So chloride, yellow brown color, chloride, ammonium hydroxide precipitate. That means it is oxidation number is 3. FeCl4, oxidation number is -1. J. K, hydrogen sulfide. Because when you add hydrogen sulfide, Fe plus 3 reacts to give you Fe plus 2. And that is how the yellow color material form. K, L is ferrous sulfide. If you want, I'll write down the reactions also. Ferrous sulfide. Yeah? Pale yellow color M, KLM, M is sulfur. M. So strong monobasic acid, they have not given a letter. Let's see what is that J. Right. J is yellow-brown color. When you add silver nitrate, it gives you a white one. So J is FeCl4 minus. Q. Q is silver chloride. Right. When you add ammonium hydroxide, it gives you a clear solution. Slightly acidic, this one. So what is that? N is N, not N, O. O is ammonium thiocyanide. Ammonium thiocyanide. Deep red color is N. N is FeSCN minus. Right? Deep red color comes with that. Ne? Slightly acidic dilute sodium hydroxide, P gives you ammonia. P is ammonia. What are the other things that we have missed? Anything you want me to explain? It says metal, no? Right. Metal, yes. Yeah, you are right, yes. I wrote FeCO3, but it says metal. I didn't see that. If it is metal, it is Fe. And this one should be hydrogen, nah? Because it says it's a metal, hydrogen. So that should be hydrogen, nah? Yeah, this says it's a metal. Nah? I didn't read that part. So this is hydrogen. This is Fe. All right, everybody, okay? So do you want me to look at the reactions? Right? So in the here you have several complexes. Fe plus 3. Na? If you have SCN1 minus, you get Fe, SCN, Fe is plus 3 minus 1, 2 plus. You can have Fe, SCN twice also. Put a plus 1. Fe, SCN3, no charge. And Fe, SCN4 minus charge. Right? All of them. Okay. So here I didn't write -4. Right? So these are the complexes that you can have. You can write anything that is there. Right? Shall we look at those reactions even though they don't ask? Shall we look at those reactions? FeCl3 is a precipitate. It's not a precipitate. No? FeCl3 is not a precipitate. Ferric chloride, no? It is soluble. Right? Shall we look at the reactions so that you can kind of understand it better? So first reaction is it's a metal dilute sulfuric gives you pale green color. So Fe sulfuric gives you ferrous sulfate. Ferrous sulfate and hydrogen gas. That's that reaction, right? And then what you do is you take this ferrous sulfate and add sodium hydroxide to it. When you add sodium hydroxide, you get ferrous hydroxide, FeOH twice, and sodium sulfate. Ferrous hydroxide is the precipitate that you get. What is the next reaction? Right. So dirty green precipitate, you add hydrogen peroxide, it gives you ferric. Oh, ferrous hydroxide. Ferrous hydroxide plus you get hydrogen peroxide, H2O2. You get ferric hydroxide. Here the oxidation number increases. +2 to +3 by 1 electron. So it's oxidation. Hydrogen peroxide should undergo reduction. Turns into water. So this is -1, -2. So 1 electron, 2 electrons. So multiply this by 2. No, right? So let us say 2 times 2. 4 plus 2 is 6. How many oxygens? Fe plus 2 turns into Fe plus 3. 1 electron. Hydrogen peroxide turns into water. 2 times 2, 4. So 2H plus. It is 2 electrons. But you can't have H plus. No? So you add 2 hydroxy. 2 hydroxy to this side. And that will give cancel out here. So your reaction is this. Fe plus 2 plus H2O2 giving you Fe plus 3 plus 2 hydroxy. Ions there. Right? So that's what you get. Yeah. So you get ferrous hydroxide means you have 2 hydroxyl, FeOH twice here, and H2O2. That gives you FeOH thrice. Yeah, forget about that pill. Make up so that's a reaction taking place in basic media. 3, 2, okay. So that's a reaction, right? So that gives you ferric hydroxide. Gray, colorless F. Reddish brown in color, you get ferric hydroxide. When you heat it, you get Fe2O3 plus H2O. 2 Fe2. 2 times 3, 6. 3 times 2, 6. Oxygen 3, oxygen 3. That is that. So this is this part. In heat, you get G. And F, you get H. F and F is, what is that? Ferrous. Ferric. So ferric hydroxide. I'm talking about F, F. And you add HNO3. When you add HNO3, it gives you ferric ions. And then nitrate ions. And then H2O. Right? So in order to balance this, you need to have 3 here. 3 nitrates. And then you get 3 water molecules. You have Fe plus 3, now it has dissolved. Fe plus 3. Now you add potassium ferricyanide, K4 FeCN6. Now what could happen? The exchange, valency is exchange. Gives you Fe4. And this one, FeCN6 thrice. And then K plus. So FeCN6 can 3 here. 4 Fe means this should be 4. 4 times 3 is 12. No, that cannot. So this is the precipitate that you get, which is blue in color. So it says blue precipitate. That is that. Okay. So we are here, right? Yeah, we are in this area. I think we discussed this also, reddish brown precipitate. Now we will look at this yellowish brown color solution. Yellowish brown color solution, colorless bad odor, ammonium hydroxide, silver nitrate. You can take that J as ferric chloride also, right? Because it's a solution. Doesn't say, yes, yellow color solution is, what is the J? J, you can say ferric chloride. It's not a precipitate. Or you can say FeCl4 minus the complex addition of large amount of chloride ions. So, right? Yellowish brown color, ferric chloride of FeCl4 minus. Now to this you add ammonium thiocyanide. So let us say ferric chloride. If you add ammonium thiocyanide, what will happen? It will give you FeSCN4 minus, right? So for that you need 4 of them. And then 4 ammonium ions. And how many chlorides? 3 chloride ions. Okay. So this is the red color solution that you get. Red color. Right? Okay. So I'll go back. I know it is little difficult to work on. Then you have this like slightly slightly acidic ammonium thiocyanide and dilute sodium hydroxide. You get ammonia. So that will also help, right? Ammonium thiocyanide in H4SCN plus you add sodium hydroxide, you get sodium thiocyanide in SCN. Plus, when you heat it, ammonium hydroxide gives you ammonia and water. So, ammonia gas is evolved, plus water is also water, right? They don't ask those reactions. I'm writing just to, like, remind you. The yellowish brown solution, silver nitrate, ammonium chloride. I'm looking at this part, okay? This part. Yellowish brown solution. If you take it as ferric chloride, what are the things that you add? You add silver nitrate. Silver nitrate, what do you get? You get silver chloride. And then ferric nitrate. So how many silver chloride do you need? 3, here 3. So this is the white precipitate. And that silver chloride, if you add dilute ammonia, it forms this complex, silver diamine complex. So that is the one that will dissolve. Okay? Right. What else? Now I am going to look at this part. This part, yellowish brown color, this section. This is the one that I'm going to look at. That is the last part in that reaction. So you have ferric chloride and you pass hydrogen sulfide to it. Ferric chloride, hydrogen sulfide. What is that? Ferric chloride and you add hydrogen sulfide to it. There's an oxidation reduction. Sulfide turns into sulfur. Ferric turns into ferrous. And then we'll balance it. Okay. So this is your one electron. Sulfide to sulfur, you have two electrons. So multiply by 2. This is multiplied by 2. This is also multiplied by 2. 2 times 3, 6 Cl minus. 6 Cl minus. Other than that, you get one sulfur, like, that is 2H plus is also there. So 2 times 2, 4 plus 2 is 6 minus 6. That is cancelling out. But then this ferrous sulfide with more hydrogen sulfide, it gives you ferrous sulfide. Ferrous sulfide precipitate and 2H plus is given. So this is the black color precipitate. So sulfur is the colloidal sulfur. Colloidal sulfur is that. So all the reactions are there. Write the complete electronic configuration of A. What is the complete electronic configuration? 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, and then 3d6 iron. State the function of E in the conversion of D to F. State the function of E in the conversion of D to F. It is acting like an oxidizing agent. Oxidizing agent. Give the relevant balance chemical equation for the stated function. අපි මෙතන ලිව්වා balance chemical equation is somewhere here, right? So this is the equation. We'll paste it here, right? Okay, I'll write it. So Fe plus 2 plus hydrogen peroxide, H2O2, turns into Fe plus 3, and the other one is water. So here 1 electron, this is 2 electrons. So you need to multiply this by 2, multiply this by 2, and then to balance it, 2. So 2, right? 2 water, 2 times 2, 4. So 2H plus here. And just to cancel this out, we add 2 hydroxyl and we add 2 hydroxyl to this side. 2H plus 2 hydroxyl gives you 2 water. That will cancel out. So our reaction is 2Fe plus 2 plus H2O2 giving you 2Fe plus 3 plus 2OH minus. That's your reaction. But then you might say, but it is not Fe plus 2, it is Fe ferrous hydroxide. So let us add 2 hydroxyl to make ferrous hydroxide. 2 neme, 4. 4 hydroxyl to make ferrous hydroxide. Let us add 4 hydroxyl to this side also. So then this will give you 2 ferrous hydroxide, OH twice. 2 times 2, 4, 2 ferrous hydroxide plus hydrogen peroxide. Giving you, so 4 plus 2 is 6, ferric hydroxide. And this is 2. State function for the stated function. I hope you got that. Everybody okay with that? So that is that, entire set of questions there, right? Right. You say now, shall we look at question number 57 also? Question number 57. These are state and form each and every element again. Just to remind, M has a cation that and that cation forms a blue color solution with concentrated HCl. So what are the blue color complexes that can form? Cation, it forms a blue colored complexes. Can. What are the blue colored complexes, children? Can somebody tell me? When you have chloride. Cobalt is there. Cobalt plus 2. තව එකක් තියෙනවා. What is the other one? Chromium, yes. Cr plus 3. So it can be both of them. Cobalt COCl4 2 minus is blue in color. And CrCl6 3 minus is also blue in color. So this can be both. Write the chemical symbol of M. Can be cobalt or chromium. Write complete electronic configuration. You can't separately identify out of those two. Right. Write the complete electronic configuration. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d7, cobalt plus 2, you don't have 4s. This is cobalt plus 2. Chromium plus 3, what is that? 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d5, 4s1, right? So out of that also we will, if you look at chromium plus 3, you need to remove one of those electrons and this will be 3d3. Agree with that? Right? Not only cobalt, cobalt and chromium both can be there. Like, we haven't given, they have, I haven't given anything else. So these are the two things that you can have, right? Which oxidation state is most likely to exist considering the electronic configuration of M? So according to this one, which oxidation state most likely to exist? Here in this case, it is cobalt plus 2 and the other one is chromium plus 3. These are the two oxidation states you can have. How would an aqueous solution containing the cation in the stable lowest oxidation state of M react with aqueous sodium hydroxide? If you look at cobalt plus 2 react with sodium hydroxide, what would you get? You get cobalt hydroxide, pink precipitate. And if you gradually allow more and more sodium hydroxide to be there, what will happen is it forms, not everything forms, but it partially forms this blue colored complex. Na2, right? This form this blue colored complex. Chromium plus 2 is unstable. Stable one is chromium plus 3, aqueous. If you add sodium hydroxide to that, what would happen? First thing is, it gives you chromium hydroxide green precipitate. Green precipitate. Now, if you add more hydroxide, it gives you CrOH 4 minus this green solution. Right? So these are the two complexes that will form. I hope all of you okay with that. Right? Under a certain condition, reaction between aqueous ammonia and aqueous solution containing cations in the lowest oxidation state of M appear to be different from that reaction in above. How do you explain it using the balanced chemical equation? Right. So cobalt plus 2, if you add the ammonium hydroxide to this, what will happen? First thing is it gives you cobalt hydroxide precipitate. But if you add ammonia to this, it gives you cobalt hexamine complex, which is yellowish brown in color. This is pink color precipitate. It dissolves to give you yellow brown color. Right? Chromium plus 3. If you add ammonium hydroxide, it will give you chromium hydroxide green precipitate. Green precipitate. But in the presence of excess ammonia, excess liquid ammonia, excess ammonia, right? It won't dissolve. It won't dissolve, right? So they are all, both of them are different. Write the formula of the chemical species responsible for the blue color of M. I have given it earlier. COCl42 minus CrCl62 minus. Write the observations and the reason when excess water was added to the chemical species of the blue color of M. So if you add excess water, what will happen is, eh, COCl4 2 minus. When you add water, it acts as a ligand. Cobalt, not amine, sorry. Hexa aqua complex, H2O, and it becomes pink in color. This becomes pink in color. Chromium also like that. CrCl4 6 2 minus 3 minus plus water. What does it give you? It gives you Cr aqua complex, which is bluish purple in color. What kind? This is blue purple in color. Blue purple color. Right. Okay. Right? Okay. Is it clear? Did you understand that? Ah, right. So that is question number 57. Shall we look at 58 also? Question number 58. We will discuss that and then we will move on to organic. 58. Only the 58. A is a colored inorganic salt containing metallic element of M. When A is heated to give a green residue called M2O3, a colorless gas called C, and water vapor. It consumes 1 mole of A to give 1 mole of B residue. C gas react with dissolved magnesium to form C gas react with dissolved magnesium to react to form a white solid D. D reacts with water to give a gas E, which turns red litmus blue. When A is heated with sodium carbonate, then E gas was formed. When green color B was heated with basic hydrogen peroxide solution, gave a yellow color solution of FMF. So what is this compound? What might be this compound? We have encountered this one. Like when you read it, now you should immediately get at least the element. Right? So basic hydrogen peroxide gave a yellow color. Green color, basic hydrogen peroxide gave a yellow color means it is chromate, isn't it? Chromium. Chromate is the one that is formed. So when A is heated to give a green residue, M2O3, ammonium dichromate. So ammonium dichromate, Cr2O7, gives you, when you heat it, what are the compounds that you get? Cr2O3 plus ammonia plus water. This is what you get. Nitrogen, two nitrogens, two nitrogens. 7 oxygen, 3, that is 4. 4 times 2, 8. So Cr2O3 is the green color residue. B. This is A. Ammonia is colorless gas called C. Ammonia. Ammonia is the gas. No? Ammonia, nitrogen. No? Nitrogen is the gas. This is not ammonia, nitrogen. Nitrogen is the gas. Nitrogen gas C. And this one 4H2O and water vapor. Right, okay. Nitrogen is the gas. That is what. Chromium is the green color solid. Okay. Water vapor, 1 mole of A gives 1 mole of B. 1 mole of A gives you 1 mole of B. That's okay. Chromium 2. Okay. C gas react with dissolved magnesium. Dissolved. So nitrogen reacts with magnesium to give you form a white solid D. What is that? Magnesium nitride, Mg3N2. Right. So this is called D. D. D is that. D reacts with water to give gas E. Magnesium nitride reacts with water to give you, what does it give you? It gives you magnesium hydroxide and ammonia. Let us balance it. 3 magnesium. 3 magnesium, 3 times 2, 6. 6 oxygen. 6 hydrogen, 6 to 12 hydrogens. This is 2 ammonia. Right. So let us look at that. D reacts with water to give a gas E. So this should be gas E. That turns red litmus blue. When A was heated with sodium carbonate. Right. So what is that? Ammonium dichromate react with sodium carbonate. What would you get? You get sodium dichromate, Na2Cr2O7. Then gas is E was formed. Ammonia and ammonium carbonate, ammonia, water and carbon dioxide. Right? Like here, the sodium ions combine with dichromate and it gives you sodium dichromate. Then this ammonium ions combine with carbonate and gives you ammonium carbonate. But because you are heating, you get ammonia, water and carbon dioxide. Ammonia is the gas that is evolved. Ammonia gas, water, carbon dioxide is given. Right. So when A was heated with sodium carbonate, then gas E is formed. Sure, E is formed. Let us check whether it is balanced. 2 ammonia. Right, carbon dioxide, ammonium, carbon dioxide, water. When green colored B was heated with the basic hydrogen peroxide solution, gave a yellow colored solution F. So when green colored B, Cr2O3, you are reacting with hydrogen peroxide, turning to the yellow colored material, CrO4 2 minus. So this is plus 3, right? This is plus 6. Plus 3 to plus 6 is oxidation. Hydrogen peroxide should undergo reduction. H2O. So here it is plus 3 to plus 6, 3 electrons, altogether 6 electrons. This is minus 1 to minus 2, again 2 electrons. So multiply this by 3. And so this is 3, this is 6, this is 2. In order to balance the charges, you need to add how many hydroxyl? 4-hydroxyl. 4-hydroxyl. 4-hydroxyl hydrogen. That means two water. Right? Double check. I'm not sure whether this is right. You can double check. So anyway, you get this thing. So A, B, C, D, E, F. I think we have labeled them. Huh? A is this, B, C, D. This is E. And then there is F. What is F? F is yellow colored solution F. F is this one, right? Chromate ions. CrO4 2 minus chromate ions, yellow colored one. F. Balance the chemical equation for each reaction. So I gave you all the reactions here. But I'm not sure whether this last reaction is balanced. Double check. Please check that. We have done this reaction many times earlier. So that is up to 58. 58. So next week, we'll try to do 59, 60. Like, try to do these remaining questions 59, 60, 61, 62. Let us say 65 up to at least that point. So in this week, not this week, this month, we want to finish this tutorial. And then I will take chemical kinetics tutorial, right? After finishing this. So we'll try to finish. There are uh, two, two Thursdays that we have in this month. So we'll finish it. Right? Then inorganic is tutorial discussions are done. Right? Now we will move on to the organic one. Isomerism part. Let me take some pages. Right, okay. Organic tutorial. We were looking at this isomerism tutorial. Isomerism tutorial, the second isomerism tutorial. I think we discussed up to question number 5 last week. I can't remember whether we discussed question number 6. Did I discuss question number 6? No, right? Question number 6. No. Okay. So question number 6. Relative molecular mass of a hydrocarbon A is 58. Right? Its molecular formula. It's a hydrocarbon. Right? 58. Relative molecular mass is 58. The question number 6. 58 grams per moles. So what is the write the formula that you can have? What is the formula that you can have? 58. 58 means like how many carbon atoms you can have? 48, like four carbons. C4H10. 12 times 4, 48 plus 10, C4H10. Is it okay? Did you get that? Right. Okay. Good. C4H10. Right. Possible structures for A. So 4 carbons, 1, 2, 3, 4. That is one of the structures. Hydrogen, 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 hydrogen. Let us see how many. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. C4H10. Or you can have this one, carbon, carbon, and then carbon. You can have the other carbon here. CH3, this is CH3, this is CH3, and this is hydrogen. This is also another structure that you can have. These are the two structures you can think of. Right? The possible structures for it. 1 mole of non-cyclic hydrocarbon B undergoes fully catalytic hydrogenation. It reacts with 2 moles of hydrogen to give 1 mole of A. What is the structure? That means 2 moles of hydrogen means you have to have either 2 double bonds or 1 triple bond, right? Should have 2 double bonds or 1 triple bond. 1 triple bond. So now for the structure like this, structure like this, you can't have a triple bond. So if I draw a triple bond here, it will violate the octet. 1, 2, like 1, 2, 3, 4, 5. Forget about hydrogens. You can't have two double bonds also like this. It will still violate the valence. So here, this is the only structure you can have for that. So what is the structure of A? So structure of A, use a different color. This color is really ugly, right? A is equal to, what is that? CH3, CH2, CH2, CH3. Right. Draw 4 possible structures for B. What are the 4 possible structures for B? You can have CH3, CH2, C triple bond CH. That is one possible structure. Other one is CH3, CH, double bond CH, CH3. That is also another possible structure for B. Or you can have structure like this, CH2, double bond CH, CH, double bond CH2. This is again another structure you can have. Or else you can have a structure like this, CH2, double bond C, double bond C, H, CH3. And these are the 4 possible structures you can have. Is it clear? If there are problems, you need to ask. Huh? 4 possible structures. Then it says B reacts with ammonia and CuCl2 to give a red precipitate. Draw the structure. That means it should have a terminal hydrogen. So B should be something like this, CH3, CH2, C triple bond CH. B. C is an isomer of B. Gives D when dilute sulfuric HgSO4 is present. D reacts with the solution. That means there should be a triple bond. So this is isomer means it should be this. This one. No hydrogen here. Triple bond should be there. Triple bond, right? Right? So that should be that. C is that. C. C. Yeah. So C is an isomer. What is the isomer? CH3, C triple bond, C, CH3. D gives D when reacted with dilute sulfuric and HgSO4, H2SO4. It gives you a ketone. What did you add? You add HgSO4 and also H2SO4. D react with the solution of acidified alcoholic 2,4-dinitrophenyl hydrazine to give a yellow colored precipitate E. What dinitrophenyl hydrazine CH3. This is C double bond O. This is CH2, CH3. What is dinitrophenyl hydrazine? This is NH2. NH. Benzene. 2,4-dinitrophenyl hydrazine, NO2 here. and NO2 here. And it removes a water molecule like that. And the product would be CH3 nitrogen, NH, 2,4 dinitroene, NO2, 2,4, NO2. And that's it. Draw the structures of C, D, E. That is C, my D, and this should be E. And did you correct it? Right? Everybody okay with that? Right. Now we'll go to question number 7. Question number 7. A and B are two isomeric hydrocarbons and each containing two sp3 hybridized carbon atoms, two sp2 hybridized carbon atoms, and two sp hybridized carbon atoms. Two sp3, sp2, and sp. Right. A shows optical isomerism and B shows geometric isomerism. Draw one possible structure for each of A and B. A shows optical. B shows geometric. Let us see optical. How does the optical work? sp3 hybrid. Let us think about one chiral center. Chiral center should be sp3. Otherwise, you can't have four different groups. So sp3. I'm going to attach one sp3 here. Then I'm going to attach a hydrogen. Then I'm going to attach the sp2 centers. Then I'm going to attach sp3 centers. That's it. That's a simple way. Hydrogen, sp3 center, sp2 centers, and sp centers. Right? So 2, 2, 2. Right? That's first one, right? The other one is geometric isomerism. Geometric isomerism means you have to have a carbon-carbon double bond. Right? So on this side, you can have hydrogen, right? And on this side, you can have a sp3 center. Oh. On this side, you can have a sp3 center. Here you can have sp center. That is all. That is one structure. You can draw it like this also. Hydrogen here, hydrogen here. And here you can have sp2 centers, CH2, CH3. And on this side, you can have triple bond CH. So they ask only one structure. So one of those structures is enough. This shows geometric isomerism. Other one shows optical isomerism. Right. How about that answer? Do you okay? You are okay with that, or you have a different version? Anything to share? Sure. Right. Okay. Then question number 8. Right. Read the question, Lillian. A and B are two isomeric hydrocarbons, each containing two sp hybridized carbons and two sp2 hybridized carbons. So two sp hybridized carbons and two sp3 hybridized carbons. When one atom of hydrogen atom, when one of the hydrogen atoms in B is replaced by a chlorine atom, it gives a compound C. Right? C shows optical isomerism. 'Sir. 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 When A and B are reacted separately with the mixture containing water and mineral acid and the catalyst Y, D is obtained. D contains 3 sp3 hybridized carbon atoms and 1 sp2 hybridized carbon atoms and 1 oxygen atom. Okay, so forget we'll try to figure it out. Huh? So 2 sp3. So meaning sp hybridized carbon atoms should be together, always together. You can't have separately. sp hybridized carbon atoms should be together because it's a hydrocarbon, right? They should be together. So now what you can have is you can have CH3 on this side, CH3 on this side. That is one structure. The only possibility, two possibilities. The other structure is CH3, CH2, C triple bond CH. Anyway, these two should be together. sp3 can be separated, right? AB are two isomeric hydrocarbons, each containing 2 sp hybridized carbon atoms and 2 sp3 hybridized carbon atoms. Right? When 1 mole of hydrogen atom is B is replaced with a chlorine atom, it gives a compound C. Then look at this one. This, if you replace this carbon, you get a optically active compound, right? CH3, C, you replace this with Cl, and then this is hydrogen. This gives you C triple bond CH. That is, this is compound C. මෙයා තමයි compound B. This is A. For A, how hydrogen atoms when you replace? There are 3 hydrogens. So nothing happens. C shows optical isomerism. When A and B are reacted separately with a mixture containing water, mineral acid, catalyst D. Tired, man. So they are separately, if you do this, HgSO4, H2SO4, 60 degrees. Mineral acid means that. Obtained, D contains, D is obtained. What is D? CH3, C double bond O, CH2, CH3. D contains 3 sp3 hybridized carbons. sp3, this is also sp3, this is also sp3. Hybridized carbon atom, 1 sp2 hybridized carbon atom. This is sp2, sp2. And 1 oxygen atom. This is the oxygen. Draw the structures of A, B, C, D, E. What is the catalyst? Y, HgSO4. Catalyst. How do you distinguish A and B using a chemical test? How do you distinguish A and B using a chemical test? You can add sodium. B gives you hydrogen and A doesn't give you anything, right? Add sodium. B gives hydrogen. No reaction in A. Add sodamide, NaNH2. B gives you ammonia. Because it has terminal hydrogens. B has terminal hydrogens. And A, no reaction. Ammonical silver nitrate. B gives you a white precipitate. No reaction for A. And then if you have ammonical cuprous chloride, CuCl2 ammonium hydroxide, what will happen? Red precipitate for B, reddish brown precipitate. A, no reaction. Did you understand that? Okay, so next week I will keep the remaining ones next week. Huh? Okay, what are the questions? Can't we put Cu? Cu number ammonical cuprous chloride. Cu2 Cl2. Cu2 Cl2. Cuprous chloride. Cu2 Cl2. not right. I am not. Tolerance reagent. Tolerance reagent is ammonical silver nitrate. It gives you white precipitate. So all these terminal alkyne reactions will work, right? So we are up to that point. What is that? Question number 8. So next week, can you do question number 9, 10, 11, 12, 12 වෙනකම් කරන්න. Question 9, 10, 11, 12, 13, 13 වෙනකම් කරන්න. Question number up to question number 30. Even say now in the like next month, I will take the kinetics tutorial here, and organic will continue. Kinetics and organic will continue next month. That is like in this month we need to finish SPD. Yeah, Komari worker, right? And so there we will stop today, and this weekend, we will not have lectures. I think we will not have the class, like because of the Eid festival, lah, right? So I updated it on the group. Please tell your friends also. But Monday we will have, right? Up to which question in D block? අපි කරමු D block එකේ I think I mentioned it. කොතෙන්ද ගන්න මං කිව්වේ up to question number 65 කියලා කිව්වේ. 59 to 65. Right? Okay, right. Good night.